Okay, so in this section, we're going to talk about partitioned matrices. And basically, we're going to divide a matrix into several pieces or blocks. And this can potentially reduce the number of operations you do when you calculate the matrix products. So suppose that A is given by this way, then it is originally 3 by 6 matrix. Then we can divide the matrix into several different small block matrix. So if you let this red ones to be A11 and this blue one to be A12 and that green one to be A13 and so on, then we get 2 by 3 partition matrix, which is given by this way. And note that the entries of the given matrix are the matrices, and we call this as submatrices or blocks of the given matrix A. So we can make use of the partition matrices to calculate the matrix product. But here, the multiplications of the partition must make sense for each matrices. So what this means is like both A and B's are partitioned in the right sides so that the multiplication really makes sense. So for example, let's say you divide A into this way and B into that way. Then we have A11 equals to 2, negative 1, 1, 1, 5, negative 2. And B1 equals to 6, 4, negative 2, 1, negative 3, and 7. Then A11 is 2 by 3 matrix. And B1 is 3 by 2 matrix. And these A's and B's are partitioned in the ways that the multiplication here, like the number of columns of A and the number of rows of B's, match each other. So that A11 times B1 really makes sense. In this kind of partition, we can calculate A times B with these block matrices. So AB equals to, well, we can say A11, A12, A21, A22 times B1 and B2. And this certainly equals to A11, B1 plus A12, B1 and A21, B2 plus A22, B2. So here, note that the order of multiplication really matters because we need to have the right size to multiply each block matrices. So matrix, the block matrix given in this way is called as the block upper triangular because it looks like a upper triangular matrix where only the upper triangular blocks are non-zero. So assuming that A is invertible and A11 is P by P matrix, A22 is Q by Q matrix, then we can find the formula for the inverse matrix of the given matrix. So let's find the matrix B such that AB equals to I sub P plus Q. So here, AB equals to identity matrix of size P plus Q is equivalent to half. So we have A equals to A11, A12, 0, A22. So note that A11 is P by P matrix and then A22 is Q by Q matrix. So we have P number of rows and columns here and Q number of rows and columns here. So you can subdivide the matrix B in the same way. So like B11, B12, B21, and B22 such that the number of columns and rows are P and P here, and number of rows and columns are Q and Q there. And this way we can make the multiplication make sense, like we get I sub P, 0, 0, and I sub Q. So for the first entry, we get A11 times B11 plus A12 times B21 equals to I sub P. And for the second entry, we have A11 times B12 plus A12 times B22 equals to 0. And for the third one, we have 0 times B11, which is 0, plus A22, B21 equals to 0. And lastly, we have A22 times B22 equals to I sub Q. So here, I think the last one looks the easiest one to work with. So from here, we can tell that, well, A22 has an inverse matrix, and the inverse equals to B22. And if you apply this to the third equation, if you multiply by A22 inverse for the both sides, then this gives you A22 inverse multiplied by A22, B21 equals to 0, or I times B21 equals to 0, or we get B21 equals to 0. Then where is B21? I guess we have B21 over here. So that gives you A11 B11 equals to IP, or in other words, we have B11 is the inverse matrix of A11. And lastly, if you use all these things into the second equation, then the second equation tells you that, well, A11 B12 equals to negative A12 times B22. And here we know that B22 is A22 inverse. So this equals to negative A12, A22 inverse. And now if you multiply by A11 inverse for the both sides, then this gives you A11 inverse, A11 B12 equals to A11 inverse, negative A12, A22 inverse, or this gives you negative A11 inverse, A12, A22 inverse on the right sides, and on the left hand side we get B12. So we solved all blocks of the given matrix B. So from here we can tell that the inverse matrix of A, which is given by B, equals to B11, B12, B21, and B22, which is the same as A11 inverse and negative A11 inverse, A12, A22 inverse, 0, and A22 inverse. So we get a nice formula for the inverse matrix of the given matrix A.